Good afternoon, all of you. So this is the week 10, and in this session, we will solve the previous year gate questions specifically on the topic of activated search process and the trickling filter. So let's start the first question. The first question, so it came in gate 2021, and the first question says an activated sludge process in is designed for secondary treatment of 7,500 meter cube of municipal wastewater after primary clarifier. The ultimate BOD of the effluent which enters into the ASP is 200 milligram per liter. Okay, so the treated effluent after the secondary clarifier is required to have ultimate BOD of 20 milligram per liter. And the mixed liquid volatile suspended solid concentration in the reactor and the underflow is maintained as 3000 milligram per liter and the 12,000 milligram per liter respectively. The hydraulic retention time and the mean cell retention time are 0.2 day and 10 day. Okay. A representative flow diagram of the ASP shown below. So this is basically the representative flow diagram of the ASP. The underflow volume of sludge wastage is. So in this question, they are asking about the underflow volume of the sludge wastage. So let's first see what is meant by underflow volume. So basically, this is the aeration tank. Here complete mixing is happening. This is a secondary classifier. So underflow basically is the QW plus QR. So now based on the question, we have to write. So So, see, based on the question, they have given the mixed liquid volatile suspended solid concentration in the reactor and the underflow is maintained as 3000 milligram per liter and 12,000 milligram per liter. Hmm. So, let's start with the question. So, given that uh, X is 3000 milligram per liter, Ritesh, could you please mute your system? Yeah, so X is 12,000 milligram per liter because MLSS concentration is 3000 milligram per liter and the underflow is, so underflow XU is 12,000 milligram per liter. Okay, so we know HRT is equals to V by Q, volume upon flow. So for volume of the reactor is equals to HRT into Q, which is equals to HRT in the question they have mentioned as hydraulic. This is the HRT, the hydraulic retention time, and the mean solution is 0.2 days. So they have mentioned 0.2 days. So 0.2 into Q. The Q value they have given as 7,500 meter cube per day. 7,500 meter cube per day, and this is also in days. 0.2 day, that is the HRT. So okay, 0.2 is the HRT. So per day will get cancelled and we will get 1500 meter cube as the volume of the reactor. Okay. Now since the question they have given as a sludge. Now we will use that. So basically mean cell residence time is also known as sludge. So mean cell residence time is equals to V into X Q naught minus QW XC QW XC. So MC sludges they are given as in the question, that is of 10 days. So MCRT will become 10. Okay. Volume just now we calculated in the reactor is 1500 meter cube. MLSS concentration is 3000 milligram per liter in the question they have mentioned. So in the question they have already mentioned the MLSS concentration is 3000 milligram per liter. Okay. So now divided by Q naught minus Q, but you see the concentration of the solids in the effluent, they have not mentioned it here, so it is near to 0. We assume it will be near to 0. So if XU is near to 0, So this whole term will become zero, negligible basically. So it will be QWXU. Okay. So now you can see that the underflow, the mixed liquid suspended MLBSS concentration, the underflow they have given us 12,000 milligram per liter. So here it will come 10 is equals to 1500 into 3000 divided by QU into 12,000. Okay. So now if you find QW, so the QW will come out to be, if you solve it, 10, sorry, 50, so QW is equals to 1500 into 3000 divided by 10 into 12,000. If you solve this, you will get a value of 37.5 meter cube per day. Okay. Now the main thing is, this is not the underflow volume. Underflow volume is QW plus QR. So QW plus QR. So QR is equals to, so we know one ratio, QR by Q naught is equals to X minus X by X. Okay. So QR, if you want to calculate, you know the Q naught. Okay. So X is 3000 here. ML basis concentration 3000 into 3000 into 7500. This is the HX. So this is the 7500 divided by 9000. How 9000? So 12,000 minus 3000. So X is 12,000. This is 3000. Okay. Okay. So if you solve it, you will get 9000. So then QR will come out to be 2500 meter cube per day. Okay. Now the underflow volume will be, so now if you say underflow is equals to QW plus QR. So QW came out to be 2500 plus 37.5, which is equals to 2537.5 meter cube per day. Okay. So again I will explain thoroughly the how we arrived to the question. So an activated sludge process is designed for secondary treatment of this much amount of meter cube per day. Okay, 7500 meter cube. After primary transfer, the ultimate BOD of the effluent which enters the ASP is 200 milligram per liter. Okay, the treated effluent from the secondary calcifier required to have ultimate BOD of 220 milligram per liter. Okay, so so 200 milligram per liter 3 is entering. Okay, and it's after treatment it should be reduced to 20 milligram per liter. Mixed liquid water suspended solid concentration in the reactor and the underflow is 3000 and 12,000. So mixed liquid suspended solid within the reactor, within the ASP it is 3000, and the underflow volume, basically here it is meaning at this point the solids concentration is 12,000 milligram per liter, and they have mentioned hydrolytic retention time and means of retention time are 0.2 days and 10 days. Okay. So a representative flow diagram of ASP is shown below. So this was the diagram. Q naught flow rate is 7500 meter cube. So and the question they have given in the reactors MLSS concentration is this and MLSS concentration the underflow is 12,000. Initially, since we know the HRT which is mentioned in the question that is 0.2 days, we calculated the volume of the reactor. We calculated the volume of reactor as 1500 meter cube. Knowing the volume of the reactor, we calculated the QW, wasted amount. So MCRT is equals to, we know this expression, we know. Okay, so MCRT given in the question is 10. So using substituting all the values and effluent concentration is very less. So we consider this amount to be negligible. So then we calculated the QW. So QW came out to be 37.5 meter cube per day. But underflow basically means QW plus QR. So this is very critical thing. You should know this. QW plus QR. Now for recycling flow rate, we using this for equation, QR by Q naught is equals to X upon XU minus X. X is the MLSS concentration in the reactor and XU is the MLSS concentration in the underflow rate. Underflow. So then we calculate the QR. So basically underflow becomes QW plus QR, which came out to be 2537.5 meter cube per day. Okay. So this was the concept behind this question. Now let's move to the next question. The next question says a secondary clarifier handles a total flow of 9600 meter cube per day from the aeration tank of a conventional activated sludge system. The concentration of the solids in the flow of aeration tank is 3000 milligram per day, 3000 milligram per liter. The clarifier is required to thicken the solids to 12,000 milligrams per liter, and hence it is designed for a solid flux of 3.2 kg per meter square r. The surface area of designed clarifier for thickening is. So basically, first we will write down the what are the data they have mentioned in the question. So design solid flux. Design solid flux is 3.2 kg per meter square r. Per meter square r. Okay. So total, and the total flow is total flow to secondary clarifier is 9000 meter cube per day. Okay. So since it is in per day, I have to convert in terms of per hour. 9600 divided by 24. It will be 9600, 400 meter cube per hour. Okay. So this we know total flow rate in meter cube per hour. Now coming back to that, in question the MLSS concentration they have mentioned is the concentration of the solid in the flow. Basically this is the MLSS concentration. MLSS concentration is mixed liquids suspended solid. MLSS concentration is 3000 milligram per liter. Okay, which we can write as, it can be, or you can write as 3 kg per meter cube. Okay, so now therefore if 3 kg, therefore solids loading to clarifier, solid loading to clarifier is MLSS into Q. Okay, so MLSS into Q basically 3 kg per meter cube into 9600 meter cube per day. 9600 meter. Very, be very careful while uh, for in terms of units. So meter cube get cancelled. So we got So Q is basically 9600 meter cube per day. Okay, so it is in per day. So 3 kg per meter cube. It should be in terms of R, because so in terms of R it will be 400 meter cube per hour. Just we calculated before this one. So it came out to be 1200 kg per hour. Okay, the solid loading to clarify is 1200 kg per hour. So now the thing is, I converted it into R because it is designed that 3 kg per meter cube R. Okay, now to know the surface area. The surface area of secondary clarifier required for thickening is equals to 1200 divided by 3.2. So 1200 kg per hour. So kg per hour into 3.2 kg per meter square per hour. Okay, so it gets cancelled RR. So we get finally 375 meter square. So answer came out to be 375 meter square. Okay. So once again I will explain this how I arrived to the question. So in the question they have mentioned a secondary clarifier handles a total flow of 9600 meter cube per day from the aeration tank of a conventional activated sludge system. The concentration of the solid in the flow of aeration tank is 3000 milligram per liter. Okay. The clarifier is required to thickening the solid to 12,000 milligram per liter. Hence, it is designed for a solid flux of 3.2 kg per meter cube hour. The surface area of design clarifier for thickening. So total, so design solid flux they have mentioned, okay, and the total flow to second pipe they have mentioned. So what I did initially, I converted into meter cube per hour of the total flow to secondary clarifier. Then MLSS also they have given. So from there I calculated the total solids loading to the clarifier, that is MLSS into Q, flow rate and in the total solid concentration. So there I got 1200 meter kg per hour. Okay. Then I calculated the surface area. Like if you see the units, 200 kg per hour divided by design flow rate, design solid flux will give out to surface area. So you got 375 meter square. Okay. Now coming to the third question. The third question says a schematic flow diagram of completely mixed biological reactor with provision for recycling of sludge is shown in the figure. Okay, so is shown in the figure. So now this schematics they have mentioned in the figure. So they have mentioned the data. Then they are asking them. They have represented what the specific unit means. The mean cell residence time is. So they are asking about the mean cell residence time. To calculate the mean cell residence time, we first know the volume, but the volume is not given in the this figure. So basically, volume the tank is equals to Q into D, days. This is a detention time, sir. Detention time. Okay. So flow rate, how much they have given us? 15,000 meter cube per day, and detention time is 2 hours. They have mentioned. See, this is the 2 hour. and this data I am using Q. So 2 hours. 2 hours divided by 24 because it is in day. This meter cube per day. So we will get as 1250 meter cube. Okay. So now the volume of the tank is 1250 meter cube. Now by knowing the volume of the tank, we can calculate the mean cell residence time. Mean cell residence mean cell residence time is equals to V into X Q by Q naught Q minus QW XC plus QW XU. There we got volume is equals to 1250 is the volume just now we calculated. So MLSS concentration, sorry, MLSS concentration is 3000 milligram per liter, which is 3000 milligram per liter divided by Q minus QW. So they have given this is the value of Q minus, but see X MLSS concentration the effluent is 0. So Q naught minus QW into X if we do it will come out to be 0 because effluent total mixed liquid volatile suspended solid concentration the effluent is 0. So this term will come out to be 0, this term. So 0 plus QW is 50 meter cube and XU 50 into 10,000 plus 50 into 10,000. Okay. So now MCRT is equals to, if you do the calculation, it will come out to be 7.5 days. So, so using this, now we got the MCRT value of 7.5 days. Okay. So before proceeding to the next question, I will again just explain you the concept. So in this, they have given a schematic diagram with the provision of recycling of solids. Okay. So in this, they have given the data of that how parameters are varying within the system, and they have denoted with Q naught, S naught, and X. Okay. So they are asking this question: what will be the mean cell residence time? So for mean cell residence time, we know for calculating the mean cell residence time, we need the value of volume of the tank. So first we calculated the volume of the tank, that is flow into detention time. So then after calculating it, we got at 1250 meter cube as the volume of the tank. Now, using the volume of the tank, we calculated the mean cell residence time. So, mean cell residence time formula is this one: Vx divided by Q minus QW Xc plus QW Xu. So, there is a twist. So, volume we calculated, suspended solid mixed liquid volatile suspended solid concentration is 3000 milligram per liter. But in the question, they have mentioned that the mixed liquid suspended solid concentration in the effluent is 0. Here they have mentioned it. Xc is 0. So if Xc is 0, so this whole term will comes out to be 0. And QW is 15 meter cube per day and XU is 10,000 meter cube per day. So mean cell residence time comes out to be 7.5 days. Okay. So let's proceed to the next question. So the next question says, a water filtration net is made of uniform size sand particle of 0.4 mm diameter with shape factor of 0.84 and specific gravity of 2.55. The depth of filter bed is 0.7 meter and the porosity is 0.35. The filter bed is to be expanded to a porosity of 0.65 by hydraulic backwash. If the terminal settling velocity of sand particle during backwash is 4.5 centimeter per second, the required backwash velocity is. So basically, in okay. So first of all, they have given the shape factor, the gravity, the depth of the filter bed, and the filter bed is to be expanded by a porosity of 0.65. Okay, so now one thing which I want to tell you in this question is porosity porosity in the expanded bed is a function of backwash velocity and terminal settling velocity. Okay, so porosity of the expanded bed is given by the formula Vb by Vt raised to power 0.22, where Vt is known as terminal velocity and Vb is known as backwash velocity. Okay, now let's now go back to the question. So the question says the porosity of the expanded bed is 0.65 by 100 with the terminal velocity of the sand particle during. So terminal basically Vt is given in the question as 4.5. That is 4.5 Vt. Okay. Now they are asking the required backwash velocity is. So if we use this formula, then porosity of the expanded bed is equal to Vb by Vt 0.22. Now we know the porosity of the expanded bed is 0.65 and V terminal settling velocity the given in the question is 4.5 centimeter per second, 0.22. So 4.5 they have given this 4.5 centimeter per second. So now if you from here you can get the backwash velocity is 6.35 into 10 raised to minus 3 meter per second. Okay, this is the backwash velocity. So option 2 is the solution. 6.35 to 10 raised to minus 3 is the solution. Okay. So now let's go back to the next question. The next question says the most important type of species involved in the degradation of organic matter in case of activated sludge process is first is autotroph, option second is heterotroph, third is prototroph, and fourth is autotroph. Okay, so basically what happens in activated sludge process in presence of food mass as oxygen, heterotrophic bacteria converts biomass in the food mass into biomass. So basically what happens heterotrophic bacteria cannot organic compound it cannot produce organic compound from inorganic sources and therefore rely on consuming other organisms in food chain cannot produce organic compounds and from inorganic sources and thereby rely on other consuming other organisms in the food chain. Okay, so in activated search process in In activated sludge process, in the presence of food mass and oxygen, in the presence of food mass and oxygen, heterotrophic bacteria, heterotrophic bacteria converts food mass into biomass, converts food mass into biomass. In the activated cell process, in the presence of food mass and oxygen, heterotrophic bacteria converts food mass into biomass. Okay, so the correct answer is heterotrophic bacteria. Now let's go to the next question. So in the next question it says the activated sludge in the aerated sludge in the aeration activated sludge is the, so four options they have mentioned. First option is aerated sludge in the aeration tank, sludge settled in the humus tank, sludge in the secondary tank after aeration and the rich in microbial masses, and the sludge in the secondary tank after aeration and the rich in nutrients. Okay. So now the settled sludge in the secondary clarifier in the secondary clarifier containing living organisms is returned to the reactor to increase the available biomass and speed up the reaction. Okay, so the returned activities from the secondary tank is active. The returned activated sludge from secondary sedimentation tank is active and hence it is called activated sludge. And it is called activated sludge. So basically, the sludge in the secondary sedimentation tank after aeration and the rich in microbial masses. So this is the correct answer for the activated. What is activated sludge? Activated sludge is a secondary sedimentation tank after aeration and rich in the microbial masses. Okay. So this was about the questions. Now we will discuss few of the concepts belonging to the ASP. So there are very design parameters like hydraulic tension time, volumetric BOD loading rate, and specific substitution rate, and lower sludge volume index. Okay, so first of all, we will start with the first thing, design parameters. Hmm. So first is hydraulic tension time. So hydraulic first is hydraulic tension time. So hydraulic tension time or you can say that aeration time, or you can say that detention time. Okay, so hydraulic detention time theta is equals to volume of tank divided by rate of flow in the tank. Okay, so basically theta is a v by q. Okay, so now there is another term which we call as volumetric BOD loading. So volumetric BOD loading is equals to the mass of BOD applied upon the volume of aeration tank. So as I told, volumetric BOD loading or organic loading rate or organic organic loading rate. So what we say is equals to what basically it means mass of BOD applied mass of BOD applied per unit volume of the aeration tank. Volume of aeration tank. Okay, if someone asks you what the okay, what is organic tank, you have to tell the mass of the BOD applied per unit volume of the aeration tank is known as organic loading rate. So basically, the formula is QS naught is the total amount of BOD that is applied in the aeration tank and the volume V. So V is the volume of the aeration tank. Okay. Now let's move to the third. What is meant by specific substrate utilization rate? Specific substrate utilization rate. So U is equals to Q S naught minus S by Vx. Okay. So this is equal called as mass of BOD removed, mass of BOD removed per unit mass of biomass in the aeration tank. Okay, mass of BOD removed per unit mass of in the aeration tank. If the value of S is found compared to, so what happens if value of S is small compared to S naught. So then you can also be expressed as V into X, QS naught by Vx. That is food applied by the mass of the MLSS. Lower the food by mass ratio, greater will be the removal of BOD. And so, okay. So another thing is sludge age. So, so this one more thing. This is mass of BOD applied by mass of the MLSS. So you can also write it as F by M. F by food by mass ratio. Okay. So now the fourth thing is sludge age. Okay, it is defined as the average time for which the biomass remains in the system. It is defined as the average time for which a biomass remain in the system. Okay. It thus indicates, so this is the first point you should always remember, it is defined as average time for which the biomass remains in the system. It indicates the residence time of biological solids in the system. Okay, so sludge is equals to sludge is basically equals to mass of MLSS in the aeration tank divided by mass of MLSS in the system leaving per day. Leaving the system. Okay, so theta c is equals to Vx divided by Q naught minus QW XC plus QW XU. Okay, so this is theta c is equals to mass of MLSS in the aeration tank by mass of MLSS system leaving the per day. The sludge is okay. So the second thing is sludge age. Basically, what happens if Xc is 0, considering Xc is less than near to 0, so it is equals to V by X by QWXU. Okay, sludge age is equals to Vx by QWXU. So you can say that it is inversely proportional to 1 upon F by M ratio. Okay, because F by M ratio we saw Q S naught by Vx, and here it is Vx by QWXU. Okay, so you can say sludge age is inversely proportional to 1 upon F by M ratio. Okay, so the second thing is sludge volume index. The so till now we have discussed up to fourth. This is fifth is sludge volume index. So sludge volume index basically MLSS concentration aeration tank controlled by one is sludge recirculation ratio, sludge settleability. Okay, sludge volume index basically it indicates the physical state of the sludge. Indicates the physical state of sludge in the physical state of sludge in the biological aeration system. Okay, basically it represents the degree of concentration of sludge in the systems. SBI represents the degree of concentration of sludge in the system and hence decides the rate of recycle of sludge required to maintain desired ml/VSS and F/m ratio in the aeration tank. In the aeration tank to achieve the required degree of purification. To achieve the required degree of purification. Okay. So basically, it is defined as volume occupied in ml by 1 gram of solid in the mixed liquid. So it is defined as volume occupied in ml by 1 gram of solids in the mixed liquid after settling for 30 minutes. Okay. Its unit is milliliter per gram. It is defined as volume occupied in ml by 1 gram of solid in the mixed liquid after settling for 30 minutes. Its unit is milliliter per gram. So what happens if SBI is higher? Sludge volumes index higher, that means poor sludge, poor settleability. Okay, and basically it means fila filamentous growth. Okay, SBI lower. Okay, it means sludge is thicker sludge and good settleability. Okay, so the value of SBI should be between 80 to 150 milliliter per gram. This will ensure there is a this will ensure that there is sufficient settleability of sludge. Okay, so this is all about. So also remember that activated sludge process is a suspended culture process with sludge return, and this process can be completely mixed and as well as plug flow process. Okay, so let's summarize the today's class first. So first question, we began with 2021 gate question based on accurate search process, and in this question the critical thing is they are asking of the underflow volume. So when they are asking about the underflow volume, it will be QR plus QW. people generally confuse it with the QW or only one QR. So when they are mentioned here, it is Q underflow, it means QR plus QW you have to calculate. So from this, we first calculated the HRT, then we calculated the volume of the reactor. Then from the mean cell residence time, we calculated the QW. After that, using this expression, we calculated the QR. So recirculation rate. Okay. So QR come out to be 2500, and then after some adding both, we got the underflow, that is QW plus Q naught QW plus QR. Okay. So this second question, we focus mainly on design surface area. Surface area, first in this question we calculated the total amount of solid loading to the clarifier. Okay, total solid loading to the clarifier. After calculating the total solid loading to the clarifier, we divided it by the design solid flux. So we got the here the we got the surface area of the clarifier. Okay. In the third, the what happens, the third in the question they are asking about the mean cell residence time. Okay, the thing, when they are asking mean cell residence time, we should know that there is a requirement for the volume. So volume we calculated by the flow rate into detention time. Okay, once we calculate the volume of the time, we then calculate the MCURT, mean cell residence time, and in the mean cell residence time they are telling solid concentration in the effluent is near to zero. Okay, so that means Q naught minus QW comes out to be 0, and thereby we got initial residence time of 7.5 days. Okay. In the next question, we calculated the backwash velocity, and in the question they have given the porosity and the terminal velocity. So we know the porosity of the expanded with the function of backwash velocity and terminal settling velocity. So using this expression, we knew that it was given, and this was given in the question. Okay. Terminal velocity was also given in the question, and then we calculated the backwash velocity. Okay. The this question, the question says what is the most important type of species involved in the degradation of organic matter in the activated stress process. So it is answer is heterotroph, because heterotroph cannot produce organic compound from the environmental sources, therefore they rely on consuming other organisms in the food chain. And in activated sludge process, in the presence of food mass as oxygen, the heterotrophic bacteria converts food mass into biomass. Okay, that is the reason that the most important type of species involved in the degradation of organic matter in case of activated sludge process is the heterotroph. Okay. Now coming to the activated sludge process. What is activated sludge process? Activated sludge process is nothing but a sludge that is active, and it is recirculated from the secondary tank after irrigation, and it is rich in biomass. So the settled sludge in the secondary clarifier containing living organisms is returned to the reactor to increase the available biomass and the speed of the reaction. The returned activated sludge from the secondary sedimentation tank is active, and hence it is called as activated sludge. So the design parameters are hydraulic retention. So then we discussed about the design parameters. So what many people have some confusion regarding the what is meant by organic loading rate, what is meant by sludge age, okay, what is meant by mean cell residence time. So first we saw what is meant by hydraulic retention time. Hydraulic retention time, aeration time, and detention time all are same. So it is the volume of the tank divided by the rate of flow in the tank. Hydraulic retention time means amount of time with which the water remains in the reactor. This is the point A. Suppose this is the point B. So the time taken, the total time the water remains in this tank is known as hydraulic retention time. Okay. Now the volumetric BOD loading, organic loading. So volumetric BOD loading is equal to the mass of BOD applied per unit volume of the irrigation tank. So that is Q naught QS naught by V volume. Then the specific surface utilization rate. Specific surface utilization rate, basically it means the mass of BOD removed per unit biomass in the aeration tank. Okay. So if value of this effluent BOD is lesser than the influent BOD, then it comes out to be Q S naught by Vx, which is equals to food by mass ratio. Okay. The lower the food by mass ratio, greater will be the removal of BOD. Okay. Now, fourth thing we studied sludge. Sludge is basically defined as the average time for which the biomass remains in the system. It indicates the residence time of biological solids in the system. Okay, and therefore, since I mentioned the mass of sludge is equal to mass of emulsion is the reaction time, the mass of emulsion leaving the system per the Vx divided by Q naught minus QWXU plus QWXU. So if X is near to zero, solid concentration of effluent is near to zero, then the equation turns out to be Vx upon QWXU. That is inversely proportional to 1 upon F by M ratio. Then we studied the sludge volume index. Basically, it indicates the physical state of the sludge in the biological reaction system, and it is important because it decides the recycle of sludge to maintain the desired MLBSS and F by M ratio in the aeration tank. And basically, it is defined as the volume of aqua in ml by 1 gram of solids in the mixed liquid after settling for 30 minutes. Okay, this test is generally carried out in the measuring cylinder. Okay, so it is units in milliliter per gram. Higher SBI means poor sludge. Poor sludge basically means filamentous growth, and that is leads to poor settleability. SBI lower means thicker sludge and good settleability. The optimum value of SBI is 80 to 150 milliliter per gram. This is because it ensures the sufficient settleability of the sludge. Okay, so this was all about today's class, and thank you for attending this class.